Hello teachers, in this set of videos we're going to look at Unit 4, Divisibility, Factors, and Multiples. So looking at the first section, we start by looking at some examples of division with remainders. So thus far we haven't done any division where there was a remainder. They were always divisible. So notice we start with some pictures. You can use chips for this, or you could have them draw these pictures, but the idea is they would group. They have 29 stars. They would group them into groups of size 6. So there's 1, 2, 3, 4, and there would be 5 left over. So notice we have a division equation and a multiplication equation. So for the division equation, there are 4 groups of 6 and 29, and then we have a remainder of 5. Okay. In terms of multiplication, we'd say there are 4 groups or 4 copies of 6. There's your 24. And if you'd add on 5 more, the result is 29. So since we're going to be talking about both factors and divisibility, we want them to see this as both division with remainders and multiplication, where here we can see 4 and 6 aren't factors of 29 because we'd have to add on 5. Since we have to add something on, 29 is not divisible by 4 and 6. We also have them do some problems with calculators. You could have them do this by hand if you want to. But something to take note of, so we have 178 divided by 19. Okay, and a lot of students, we haven't talked about decimals yet, but they will see this and they think of the decimal as the remainder, and in a way it's what remains, but it's not how we formally define the remainder. So they might want to say the remainder is 3, or they might even round up to 4. Okay, so when you have them use the calculator, I would want to show them, well, we have 9 whole copies of 19 in 178. So 9 times 19 copies plus something. We want to see what that something is. So find 9 times 19. Well, that's 171. So you could either subtract, or there's 7 more to get to 178. And that would be our multiplication equation. And then in terms of division, we'd have 178. We divided by 19. And there was 9 copies, remainder 7. Okay, looking at the next section, we define factors and divisibility. So basically we say that a factor is when the product of 2 numbers equals a number exactly. So this would basically be 0. Divisibility, there's no remainder, so this is 0. So again, we want to connect and contrast this word factor and divisibility. So you may think a good example is 30 divisible by 6? So think about how you could justify this. You could say 30 divided by 6 is 5 and there's no remainder. You might also say that 30 is divisible by 6 because 6 times 5 equals 30. So 6 is a factor. Okay, and 30 is divisible by 6. So we often use these type of justifications interchangeably without justifying them. So we want to make sure that our students connect these ideas and these language. So they are connected, but they're different. Okay, so in these examples, we give them either a factor or divisibility question. We have them write the corresponding question in the other form. And their answer with justification could be either of these. So if it is a factor, they could, or if it is divisible, they could write one of these 2 things. Okay. If it's not, they'd have a form that has a remainder, or that has the product plus some value, which would mean the remainder is not 0. These are not factors. Okay. Looking at the next section. Then we want them to find all the factors of a number. Okay, so here there's a table of perfect squares. You can use this idea if you want to. Let's just look at an example, and let's look at 90. Okay, so one way to do this, I need some sort of systematic method. Okay, so the way I used to teach this, and I still kind of teach it this way, 90 is 1 times 90, then you try 2, that works. If you try 3, it's 3 times 30. 4, well, I'm looking here and I see this isn't even, so 4 won't work, but you might want to divide. It would go in to 22 plus 2. Okay, so that's 88 plus 2 is 90, so that's not a factor. 5 goes in, let's see, 1 18 times. 6 goes in 1 15 times. And you know the rest. Okay, so it's important that they have a process because you've probably seen students do this. I didn't happen to know off the top of my head that 5 times 18 was 90. I would know 5 because this ends in a 0, but 6 times 15 is not in our factor tables. It's not something that we have stored as a multiplication fact. Okay, so if they don't have a method for doing this, they typically skip some of the factors. Also notice here I stopped at 9. You probably know why. Okay, at this point, if we move on to 10, these numbers start to get larger than these numbers, and that's how we know we're done checking factors. Okay, so the table of perfect squares gives them a benchmark, and we use this idea for primes. I think it's more useful for primes or checking whether a number is prime or composite. But you might want to set them up here. So notice 90 is between 81 and 100. So the largest number we have to check is 9. Okay. And you can basically think of this, since we haven't talked about square roots yet, but you need to check up to the square root of 90 and then take the floor. So the square root of 90, which is some irrational number. So this is a way of kind of seeing that idea. And the basic justification that we have a video for this, or we used to, is we use this idea of rectangles. So if you got to 9, 10, maybe it looked like this. You'd have a 9 by 10. Okay, when these numbers start to get longer, so we'd have 10 and 9, you're just making the same rectangle just in a different dimension. Okay, so once we go up to here, we've checked all of these already, and you don't have to keep going. And some of them will just keep going on and on forever, and some will get bored and just start thinking of the ones they know. Let's start the next section in a new video.